Thank you.
Hello everyone. I'm happy to have you all here. Thank you for joining today's webinar. We are going to be talking about GraphQL Federation and how to migrate from monolith to a microservices architecture. We are going to be talking a little bit an introduction of GraphQL, just to take some basics there. Also talking about the monoliths versus microservice benefits. So then we are going to move to the introduction to GraphQL Federation. We are going to talk about some concepts. Then moving to the benefits of adopting a GraphQL approach, a GraphQL Federation approach to our companies. And at the end, we are going to do a basic, like step-by-step way to migrate to Federation, and we are going to know that is not as complicated as maybe it may sound. So, well, moving a little bit to, also you can start putting the question in the QA box. At the end of the webinar, I will be happy to answer as much as I can. We are going to start introduction to making a little introduction to GraphQL. So what is GraphQL? GraphQL is a query language and a runtime for APIs that enables efficient data fetching and manipulation. Basically, one of the things I like most about GraphQL is that this query language that allows us to request just the information that we want to have from the server instead of for example, a RESTful API, a traditional RESTful API, where we kind of need to adjust to the contract that they return us in a response, and then do like other operations to bring more information if we need it. So one of the or multiple of the benefits from GraphQL, one of them is that is a strongly typed schema definition language, or SDL for short. Basically, this SDL allows us to have an explicit and self-documented API with a strong type safe, and also this also allows us to have an introspection tools or a set of introspection tooling that can help us at the moment that we are trying to generate a query or a mutation. That way allow us to know which patterns we can send and which attributes we should receive and their types. Also, we have the queries and mutations are declarative thanks to the schema, and we have an efficient data retrieval through resolvers when we can have some libraries that, for example, Apollo provide us to at least for example, the REST data sources that can help us to bring information through different sources that could be a database or could be a third-party endpoint, and also kind of out of the box approaches, like, for example, some catch that we can easily implement with this. So as part of the structure of GraphQL, we have the built-in types. Basically, they are composed by some scalar types that could be an ID, which is a special type in GraphQL, but we have floats, a string, booleans, integers. Also, the types definitions are very important to define types, and in which we have, for example, interfaces. We have type, the inputs, enums, unions, and the type modifiers that allow us to basically determine if a field is going to be mandatory or is going to be optional, or if we could have an array. For example, in this definition, we are saying that the array or the field is mandatory, so we can receive a null value, but inside of the array, we should have, or we can have an empty array. So combining all these built-in types, we have basically an schema, or we are able to define a schema where a basic schema usually is composed by a query and mutations, which both of them receive, for example, the queries can receive some parameters, and we know the type that we are going to return for those queries. Also, we can define interfaces as, for example, as a user interface, and we can define custom types that implement those interfaces. And also, well, we can have other types like, for example, the enums. So this is like one of the most important part of GraphQL, which is basically the schema. So in general, how a GraphQL server works, basically we have a client that could be a web application, or could be a Android or iOS application, where perform a request. GraphQL server get that request, and because of the schema, who knows the types, let the GraphQL server, with the help of the resolver, which there is the resolver basically is a set of functions that knows how to resolve the fields that we have defined in the schema, and with the help of the data sources that basically they are the ones that help to get or bring the data from maybe the database or a third-party endpoint, or maybe another data source. So with these three kind of set of components combined, the GraphQL server can get the information that he needs, and then combine the data that received from the resolvers, and return a response to our clients. So this is kind of a basically resume of what GraphQL does and how it works. So moving a little bit to the monoliths and the microservices to have some context. In the case of the monoliths, usually we could face different problems when we are working, for example, in a large project. Sometimes it's hard to combine the efforts in the moment that we are or we are developing a feature, because we could have different teams working on the same set of functionalities that could lead to having problems maybe at the moment that we are creating the pull request, for example, have some conflicts there, or maybe a change that one team did could affect maybe another team functionality that also is being worked during, for example, a sprint. Also, in a monolith, sometimes it's hard to have a deployment process because let's say that we set a deployment process of a week. In that week, we have a lot of changes, but if we introduce a bug in one of those changes, and other teams did have also some changes in the same release, if we go to production with that and we need to make a rollback, we are going to lose also the changes that the other teams has done. And we need to make a rollback, lose those changes, and fix it to then being able to make another release. So one of kind of the cons of the monoliths is that they are tight coupled in terms of the functionalities and the code. We have a centralized deployment because of to be a monorepo where we have all the code, and of course the centralized deployment in terms of we have just one single deploy that could go wrong if we don't take care or take a special care of it. Also has some scalability limitations because of we have a big server, which is probably cost a lot of money to scale in terms of resources of memory or process that compared to, for example, the microservices. And development bottlenecks, as we talk about, maybe code conflicts or even feature problems that the different teams have defined in their during the sprints. And on the other hand, we have the microservices, that basically the microservice architecture is an approach where applications are broken down into small independent services. In here, we have benefits for scalability. For example, if we deploy microservices to AWS, it's very easy to scale in terms of memory and resources. We are resilient to changes. So as we have a team and just one team shares, for example, for a microservice, and we don't have two or more teams trying to deal with the same changes. We have flexibility at the moment of the deployment, because one team for one microservice could have a deployment process for a week, but other team with a different service could have a daily deployment process, and even maybe deploy to production multiple times in the same day, and shouldn't affect at all what we have in the other services. And tech diversity in terms of, for example, the language that we use. We can have a service built in Python, and we can have a service also built in Node, and they should work perfectly together when we join all the services in a single application. So having that context about the microservices and how how GraphQL works, then we are going to move a little bit to GraphQL Federations. So what is the GraphQL Federation? GraphQL Federation is an architectural approach that allows us to build distributed graphs system using microservices. So basically what this means, in a GraphQL Federation, we have a super graph that combines all the graph APIs in a single request. Basically, this super graph contains all the schemas that will have those microservices with additional metadata. So we have just a big, or not a big, but a super graph that knows which microservice has which data at the moment that we create a request. The subgraph knows how to trigger the different subsequent requests to get the data and gather everything together to respond just a single request. In a federated architecture, allow us to distribute the ownership of the supergraph across different teams and services, enabling collaborative development and management. So now that we have kind of our business domain split in different microservices, of course, this help us in terms of development, and we can assign kind of an ownership for each team to own one service, could be one or more. But we know that team is in charge of that service, and that can even improve or boost the productivity and the way of we implement things in that microservice. So giving a little difference between how with a monolith we usually work is that we have in the client, we could have different graph. In this case, I wanted to example it the way that we have, for example, one graph for one business domain could be an account domain that is in charge of the users and everything related to the users. And we can have a second graph entirely independent, but part of the same structure about maybe it could be, I don't know, products, everything related with products. So if the client wants to gather information about how many products maybe were bought by a user, then needs to make two different requests to get first the data for the user, and then with that data go and check on the other GraphQL server to get information for the products, and then gather all the information in the client, and basically kind of doing what we are trying to avoid with GraphQL, basically avoiding doing kind of a traditional RESTful API. So with Federation, we have and this is a new concept, the router. We'll be talking about this a little bit later, but basically the router is in front of our federation, and basically it acts as a kind of gateway. Basically, it takes all the requests from the client and the router with the information we have in the supergraph, generate a query plant where it knows which subgraph needs to call to gather the information that the client is requesting. And after that, then the router, with all that information, combines that data and return a single a single request to the client with all the information that the client needs and requests. So some benefits of adopting GraphQL Federation are that we are, of course, breaking up the monolith code to small pieces that are more maintainable and manageable. Also, we could do, and this is very important, we could have an incremental adoption of Federation. We don't need to move an entire GraphQL server to Federation in a single batch, because sometimes that's hard to do in terms of time for the company. So we could have an incremental adoption, and it's perfectly fine. And we are going to see that is not as scary as it sounds. And also we have separation of concerns. Each subgraph or each microservice belongs to a domain, a business domain, and we don't have mix up in the same server different business domains doing different things. And with the managed federation, basically what we are going to be focused on this webinar. Apollo allow us to have a managed federation and help us to have a managed federation where we could have a lot of benefits. We are going to see this at the end of the webinar. But also wanted to let you know that we could have also a self-hosted federation where, of course, we as a company need to take care about observability, about different things that with the managed federation we have out of the box, but still it's possible, depend of the what we want to do in the company. So moving to federation basic concepts, we start with the subgraph. Basically, a subgraph is a standalone GraphQL server, which is some schema file with solvers and data sources. So basically, a subgraph is a small GraphQL server, usually owned by a single team. That is ideal. One team can maybe own one or more subgraph, but the idea is that the one subgraph is just owned by one team. Also, the ideal is that the subgraph belongs to a business domain and no more than one. Basically, a subgraph in terms of infrastructure is a microservice. And because of that, we have the benefit of the microservices to be scalable and maintainable through time. Then we have the concept of the router. As I said, the router is responsible for accepting incoming operations from client and splitting them into smaller operations that can each be resolved by a single subgraph. Basically, again, the router is in charge of taking the request and through the supergraph schema, know which subgraph needs to make a request for to get some data, and then collect all that data and return it back to the client. The router could be managed by Apollo, or we could have a self-hosted router that well, we need to take care of combining like or composing this supergraph. And the supergraph is a concept that we have been talking a little bit. A supergraph is composed of multiple subgraphs, which when integrated with the GraphQL router, unleash the power of federation. Basically, a supergraph is composed by one or more subgraph. The supergraph is basically the supergraph schema. So we have in the supergraph schema or the subgraph schema with additional metadata that will allow the router to know which subgraph needs to make a request in order to get which data and resolve the defined types that we have in the schema. And we have a Rover CLI command line. This is a tool that basically help us to manage and maintain the graphs. And the subgraph is developed by Apollo, offers powerful utilities for seamless integration of our supergraph with Apollo Studio. Basically, Rover will be our like a best friend when we are developing with Federation because help us a lot to perform different tasks that we need to do. For example, one of those tasks are we can publish a subgraph to Apollo through a Rover. Also check schemas. Basically, check schema. What it does is validate that our subgraph schema is properly defined, doesn't have any error, and also it is able to compose the supergraph correctly. Also, with the Rover, we can compose the supergraph. This is just in the case that we are having a self-hosted federation. Because the compose of the supergraph is managed automatically by Apollo Studio. So we are going to see this a little bit later, and of course improve the development flow because we can integrate Rover with any CI/CD pipeline. So basically, for example, we can integrate Rover in GitHub Actions. So at the moment that we create a pull request, we can run a subgraph check where we can see if we have any error when we are composing the supergraph, and so that way we can know maybe we are having a breaking change in our schema because being able to fix it before moving those changes to our base code. So moving to migrating our GraphQL to Federation. First, this is like an example company that I call media makers. Basically, the main idea is that we have some type of users that are producers that they upload to this application some indie movies or series that maybe they want to let the world know. And so there are another type of user that can subscribe to these producer accounts to be aware of when they are publishing videos or publishing the movies or the series. Also, the subscriber should be able to make donations to the producer. So that's basically kind of the goal of the application. So we identify these domains for our monolith example. So we have an account domain that is in charge of the producers and the subscribers. We also have a media domain, which take care of the movies, the series, the seasons, and the episodes. We have a transactional domain that take care of the donations and everything related with payments. And we have another domain that is enrollment domains that is in charge of the subscriptions and future metadata about and metrics on how much a user subscribed to a producer and all these features that we can implement. So having that into account, this is how our monolithic schema looks like. We have some queries to get producer, subscriber, movies, and series. Also some mutations where we can create producers and subscribers, movies. Also, we can donate to producers. But the important thing where I want you to focus a little bit is the definition of these types. We have a producer, which implements the interface user, and the producer defines two fields. One field is the subscribers, and this field media. So the producer, as we saw, belongs to the account domain, as it is also the subscriber, but we have another domain, which is the media domain, that is going to be taking care of this field, because, of course, the account domain doesn't know anything about how to deal with media. So we are going to have a different domain or subgraph to taking care of the media. The same happens for the subscriber, which implement users and belongs to the account domain. And in this case, for the subscriber, we have the field subscriptions that return enrollments, which belong to the enrollments domain. And we have liked media, which belongs to media that at the same time make part of the media domains. So of course, the account domains won't take care of these fields for us because they belong to different domains. And well, we have the movie and the series. That the things that I want you to focus here is that we, for both of them, have a producer field that they need to resolve, but this producer field should be resolved by our account domain, which is basically the ones that own the producers. And well, the enrollments type that basically take care of the relationship between the subscribers and the producers. So, well, starting the migration, we move to Apollo Studio website, where we are going to create a new graph. So basically, we need to go to this part of the website, click on this down arrow button, and we should see an option that says New Classic Group Graph, because of course we want to upload to Apollo Studio our monolith that is the current server that we have. Of course, Apollo led you to, if you want to start with a federated approach, you can create a federated graph, but it's not our case right now. So then we click to the next button, and this is important, this information, to save it to an env file in our project, because we are going to use a lot the Apollo keys, which basically are the keys that will allow us to authenticate in Apollo Studio, and will be used by the rover CLI, the Apollo Graph Ref, which basically we defined that our graph was called Media Makers, and this add sign that we have here and the following string define a variant. Basically, a variant, we can see it like as an environment. Usually, for example, we use the variants like I want to have a variant for staging. I want to have a variant for another environment like production. Usually, current is production environment by the parents that Apollo follows. So I don't have a slide for this, but basically we click on this local schema tab, and there we just copy paste our schema that we have in our base code. We paste it there. Of course, there is another ways to do it, but this is like the easy one. We paste our schema there. We click done, and with that we have created our definition of our monolithic in Apollo Studio that we are going to use later. So moving a little back to business in the code, of course, we need to install a subgraph dependencies in our project because we are going to need it. So this is the way to do it from the package of Apollo. Also, in our schema, in our current schema for the monolith, we need to add this kind of import statement where we are importing the directive key. This directive key will allow us to create entities, and we are going to talk a little bit more about entities later in this in some slides later. But basically, what is important here that we need to import the key directive in top of our schema in the monolith. So now converting our monolith Apollo server to a subgraph. Basically, what we need to, and this is how a normal Apollo server looks like, where we pass as a parameter the type definition and the resolvers to the Apollo servers, and we make it run in a port. In this case, we are making run in a 4000 port. But then when we are going to create the subgraph, we need to import from the dependency we just installed, the Apollo subgraph. We need to import the build subgraph schema. So to the build subgraph schema, we send the type def and resolver as a parameter. That function is going to return the subgraph schema, and we pass that schema to the Apollo server that we currently have. And we need to run the subgraph in a different port, so we need to change the port of where we are running this subgraph. This is because we are going to run our router in front of the subgraph, so we need to later we are going to see it run the router in the same port that our monolith was running. So with these changes, now we have created our first subgraph. As easy as that. You have created a first subgraph, and you are now in federation. Of course, it's not what we desire, because this is still an entire big and huge server, but at this moment it's a subgraph, and this is what it takes to create a subgraph. So now we are going to convert our monolith, which is a graph in Apollo. We need to convert it to be a federated graph in Apollo. The way to do that, and we need the help of the rover CLI, and basically what we are saying to the rover is that we want to publish to Apollo this subgraph that we have defined. We are going to publish to the media maker's current graph, and this is important because this subgraph, we are going to name it our monolith, because it has all the information, and we are going to say that the routing URL where we are going to receive requests is this one. Of course, we are working in localhost, so and we have the ports that we define for this subgraph. Of course, we need to send the GraphQL schema as a parameter, and this parameter is really important this first time, because we are converting the graph to a federated graph in Apollo. So the first execution of this command, we need to run it with the convert flag. So after that, we have just published our monolith to Apollo, to a monolithic subgraph, and Apollo automatically have created the supergraph schema for us and define it in Apollo. So with that, basically have defined our first subgraph, and now we need to run the router in front of that subgraph to start taking requests and being able to route to the correct subgraph information. So for that, we basically need to download from Apollo the router. Basically, this is a compiled server, and we need to add some configuration. This is not required, but at least a development at the moment that we are making developments, it's important to have this configuration, because by default the router doesn't send any logs of errors to us, so it's going to be harder to develop without them. So basically, this configuration enable the errors, so we are able to see them. And this is just an example. Usually, of course, we have authentications in our servers, so we need to configure the router to propagate the authorization header through all the subgraph. This could be all, this could be a specific subgraph. For example, we maybe could have another header that we want just some specific subgraph to be able to receive. So we can define that here in this configuration, just passing the specific subgraph that we want to propagate the header, and that should be able the router to send the header for those ones. And this is just the way to run our router. Again, with the Apollo key and the Apollo graph ref, we know the router to connect to Apollo and download the supergraph, because the supergraph, remember that we have it in Apollo. So the router is able to connect to Apollo, download the supergraph, and that way know which subgraph needs to then make a sequential request. And of course, passing the config by parameter. So, well, we have our first subgraph, which is the monolith. Now we want to start migrating actually our monolith. We have, basically, we are going to create a new subgraph. Let's say we have a new folder for the subgraph account. And as we told, a subgraph is basically an Apollo server. So this is a boilerplate code for a new Apollo server, sorry, where we running in a port, and of course, a different port. In this case, we are running it in 2002. And in this case, we are just setting a name of the subgraph to being able to log it in the console. And important again, importing this the key directive in our schema. And well, this is just a basic resolver that we can start working on it later. So for the migration, then we start with the interfaces. We start migrating the interface to our account. So our first interface that is part of the account domain is the user interface. So this is how we had, or this is basically the final result, the way that the schema will be in the monolith. And basically we have moved all the attributes to the subgraph account, and so we define the schema of the subgraph, the new interface. This is because all these fields are going to be resolved by the subgraph account, but still we need to keep the ID field in the interface, because basically the ID for the case of the users is our primary key, and we are going to be able to identify the accounts or the users by the IDs through the different subgraph. So that's why we still need to keep this basically primary key in the monolith schema. So we have been talking a little bit about entities. So what is an entity? Basically, in a supergraph, an entity is an object type that can resolve its fields across multiple subgraphs. It should each subgraph can contribute different fields to the entity and is responsible for resolving only the fields that it contributes. So basically an entity is a special type for the federations where we can have this type to be resolved by different subgraph, but the subgraph doesn't need to resolve just the fields that they define. And basically we shouldn't have two subgraphs to define the same fields for an entity. So and this is where the add key directive highlights, because we define the entities through this key. And also there are two types of kind of ways to handle the entities in the subgraph. One is for those subgraphs that resolve fields for the entity, they need to define a reference resolver to basically the subgraph resolve those fields for the entity. And for those subgraphs that doesn't add any field to the entity, they just need to return an entity representation of that entity. So that basically will be passed through the different subgraph, and the router should be able to know which one is going to, which subgraph is going to return the data that is needed. So defining the producer entity. This is like the original way in the monolith that we have defined the producer. Of course, we move all the attributes that are going to be resolved by the subgraph account. We move it to the subgraph schema. So that's why in the subgraph schema, we define a producer that implement the user interface that we define, and with this way we are defining that this is an entity. So we are saying basically that the fields, we need to pass some fields to the key, and basically the fields that we need to pass are the way that we are going to identify the producers. Could be one or more parameters depending on what the primary key is. For our case, the primary key that allow us to get the producers are the ID. So that's why we define the fields for the entity, just the ID, which is the one that we need. And of course, our monolith is a subgraph and is resolving also another field that eventually, when we migrate the media subgraph, should be resolved by the media domain. But in this case, at this moment, it's being resolved by the monolith. And so that's why we need to define also the entity inside of the producer, because we need to resolve the media field in the monolith. And we have the same kind of the similar approach for the subscriber. We move all the fields that are the subgraph is going to take care to the subscriber, to the subgraph account schema, and we keep the fields that are going to be resolved by the monolith that doesn't belong to the account subgraph, and we define them as an entity. So after that, we can publish our schema, and well, we can publish a new subgraph, basically using the same rover command, but changing the account, which is the new subgraph name, and of course the routing key, where is basically the rover is going to make a request to this URL, of course sending the schema. But what happened if we publish this subgraph at this moment? We are going to have an error, because and basically the error is going to say that we have non-shareable fields like the name or all the attributes from the producer, and this is because we haven't published first the monolith subgraph, where we have this field defined, and we haven't published the latest changes where we remove those fields. So that's why kind of intentionally I put that the order for this is first update the subgraph monolith and then actually update the new account subgraph. So with that, we are good to go at this moment with the subgraph. And of course, we need to resolve this data. And basically, what we had in the monolith, for example, for resolve the attributes of the subscriber, we were resolving it by getting from the data source the information. But now that this is part of the subgraph schema, we need to remove it from the monolith, and that belongs to the account schema. So basically, in the producer, as the subgraph account is the one that is going to be resolving all the information related to the producer that belongs to this subgraph, we need to define the resolver reference that we were talking about a little bit earlier. So basically, this resolve reference is the one that is going to return the producer information, and as the subscribers belongs to the subgraph account, we also need to resolve the subscribers object inside of this subgraph. And of course, we remove it from the monolith, but keeping the media resolver for the producer, because still the monolith is taking care of the media resolver. And a similar way we do for the subscriber. In the subscriber, we know that this field doesn't belong to the account, so we keep it in the monolith, but we still need to define the resolve reference, so that way the router knows to get this information from the subscriber, and we should be able to get it correctly. And for those fields that, like for example, we saw the series that have the producer or the series that has some fields that return a producer type, we used to, of course, go to check the producers directly to the data sources. Now we just need to return the entity representation, which is basically the ID, which is the primary key that we've been talking about, to the router, so that way the router knows that this producer is going to pass it to the account subgraph to return actually the producer information. And well, then we of course need to migrate the queries, and then on the resolver for those queries and mutations. But well, now that we already have defined the types, it's more easier to move the queries and mutations to the belonging subgraph. In this case, the account subgraph. We move the producer and subscriber because these queries belongs to this subgraph. And of course, we need to remove them from the monolith schema and resolver. So some advantage that we have, or resuming a little bit all we have talked about how to migrate to Federation. Basically, first we need to define our business model and have a clear way of the domains, and so that way we can maybe create some subgraph per domain. Also, we'll start migrating the interfaces, define the subgraph entities as we did, also the reference resolvers, return the entity representations, and migrate the queries and notations too. That basically moved me to the part where I want to show you a little bit in some minutes how this looks in Apollo. So basically, in Apollo here we have this is the schema. These are the fields, and for example, the DSDL for the supergraph that is composing Apollo. As you can see, have some metadata that let the router knows which subgraph needs to go and make requests to gather some information. Here we can see like the schema for each subgraph independently, the account schema, what is defined, the monolith schema, also what is defined, and some nice things that we also can see are that we can kind of keep track of the changes we do to the schema. So we can see when we make some changes to our schema, also know if maybe we can some breaking changes. We can have the list of our subgraphs and which routing URLs we are then served. Also, we have all the fields that could be queries, could be mutations, and we can have a lot of metadata related to them. So for example, if I go to movies, I can know all the attributes that are defined for the movies type. Also, we can have a list of the clients that are making requests to our supergraph or to a federated graph. In this case, it's showing like there are just unidentified clients because we have not like implemented a GraphQL client, and we has been just using the Apollo Explorer to make the request. But we should see all the clients that we have. Also, we can have metadata on, for example, a query that we are making. Let's take this query as a sample. This is a query that I did as a producer with media. And we can see how long those queries are taking, so we can address maybe changes to them to improve performance. And also we can see even the query plan, how the router is defining how to get or gather the information. So we can see that, for example, for this query where we are saying that we need to the producer to return us also the media, which we know that the media is taking care of the monolith subgraph, but the subscriber is taking care of the account subgraph. We can see in the query plan that the router is fetching the account, also fetching the monolith subgraph, and then is putting all this information together and returning to the user. If we want, we can see like how basically the router define the query or translate the query plan from the query that we just sent. And yeah, that's just a sneak peek of the benefits we have from the federating approach. So yeah, I think, thank you for your time. So we can move to QA. If you have any questions, I will be happy to answer. I hope that this being helpful for you guys to understand a little bit how Federation works, how to migrate it, and knowing that it's not that hard, that we can move it incrementally. And yeah, if you have any question, you can find me on Twitter. Also, I have this sample repo in GitHub, where you can take a look at the monolith and the changes that we did for the migration to Federation. Thank you for your time, guys.